Welcome back to the arcade and another arcade fix. Today again we're going to do something a little different. This right here, believe it or not, is an oscilloscope. Cute little bugger, isn't it? This is a Tektronix 211 oscilloscope. It's a single channel oscilloscope. I believe it was manufactured around 1971-ish, around that time. And it was given to me by a friend of mine about 20, maybe 25 years ago. I've had it a right good while. When I first got it, I took it apart and figured out that the batteries were bad. This does run on batteries. It does have an AC power cord. Okay, but it doesn't run on AC. The power cord is only to charge the batteries, and if you use it with the power cord plugged in, it will extend the battery life because it basically charges the batteries. So it doesn't put out power to actually power it. It gets its power from the batteries, but this will help maintain the batteries a little bit longer in use. But it's primarily made for battery use only. And it does have, I've already had this apart because I had to figure out what batteries I needed for it. And these are it comes with 2 battery packs which go inside the unit. And they're 5-cell packs. So these are nickel-cadmium batteries. So that would make these 6-volt packs, 6 volts a piece. According to the schematic, I did download the manual, which has a complete schematic and tells you all about it, parts breakdown and everything. So if we need that, we at least have something to go by. These batteries hook in series once you plug them in through the circuit board. So it's basically 12 volts that this runs on. Now you could probably go in there and I believe I've seen somebody online that posted a video. They were doing the same thing, replacing the batteries. And you can make a modification and run it off a 12-volt power supply. Well, I didn't do that. So I've never actually powered it up and see if it works. I only remembered about this. I'd totally forgotten about it. But back when I was making the test boards for the HP comparator, that's 2 videos ago if you want to see that. I didn't have a test card, so I was making a test card, so I needed a scope to view the signal, just to verify it was working. So I wound up on eBay. I bought this little digital scope, which worked fine for the job. And I got to thinking, I said, well, I wonder if this scope would have worked. And I just got thinking about it. I said, well, I don't know, let's give it a shot. So I went ahead and I ordered a new set of batteries, 2 battery packs. And these are ni-cad batteries, and they're 6 volt each pack. So we're going to wire them up. They come with the solder tabs on them. They're already made into a pack. So all I got to do is take these apart, desolder the pigtails, and I'm going to reuse the pigtails and the original connectors. Now there's a possibility that this won't fix it. A couple of these were very similar to this. They have several models of this. This is the single channel model. They have one that's a dual trace scope. They even got one that's a hybrid, which actually has a digital multimeter made into it, where it actually puts uses the vectors on the screen as the display for the voltage, which is pretty neat. But of course, this is the very base model. It's just the single channel scope. And these are the specifications for it right here. I'll just go through it real quick. The 211 oscilloscope is a single channel, 500 kilohertz portable instrument using all solid state and integrated circuit components except the CRT. The small size of the 211 makes it an extremely portable oscilloscope for on-location maintenance in many fields of application. The instrument is mechanically constructed to withstand the shock, vibration, and other extremes associated with portability. The DC to 500 kilohertz vertical system provides vertical deflection factors from 1 millivolt at reduced bandwidth to 50 volts division at the tip of the high impedance probe. The trigger circuits provide stable triggering from about 7 hertz to 500 kilohertz from either an internal or external source. So that's just a basic rundown of it. For back in its time, I'm sure it was great. There's probably not many uses for it today. I guess it would probably shine working on audio circuits, audio amplifiers, maybe something in that range. But who knows? If you have ever used one of these, let me know. What did you use it for? What type of repairs? Or what did you actually use this exact scope or one of the others that are very close to it? Be interesting to know. Okay, so I did print out the schematic for the power supply section. There are a couple videos online where after they replaced the batteries, they had a problem in the power supply circuit. Mostly it's either bad solder joints, dirty connections, or shorted tantalum capacitors. Yeah, the dreaded tantalum capacitors. So first we'll go ahead and we'll put the batteries in, and then we'll find out, we'll check the power supply and see if we have any shorts, and we'll go from there. Let me give you a close-up of here real quick. It's a cute little scope. It has a little kickstand on the bottom. It has your controls here for your volts division and your timing second division right here. And then on the side right here, it has the step attenuator balance, volts division, positioning, horizontal, I guess magnification, MAG, intensity control, the level slope for the trigger, internal, external. Here's the power button, off and on, and it's got the input coupling, AC, ground, and DC. And it has this cute little battery meter here where you can read the battery strength. And this looks like an input for the horizontal input. It looks like something got hot there at one time and it sort of melted it a little bit. And that's the ground. So yeah, I guess that's for external input. I don't know, I'd have to go through all this. On the back, it has a place where it stores the power cord and the probe. It comes with a built-in hardwired probe, which is kind of neat. A lot of times the probes are missing on these. The wires have been cut off. I think I've seen one or two on eBay that were like that. I'm sure that, I don't know if you could use a standard probe or not, but this is in pretty good shape. I even have the carrying case that this comes with. It actually has a, I don't have it out here with me, but if we get this working, I'll show you the case that it comes in, and that's what probably kept this in such nice condition. If I had to bet, I would say my buddy got this at a NASA auction. He works for a contractor, a company's electronic technician, and they contract out to NASA. He's worked a lot out at NASA here locally, and he's worked in the wind tunnels out there and all that kind of stuff. So anyway, he used to frequent a lot of their auctions. They would have auctions, government surplus auctions, where they'd auction off old equipment. And I'm sure that's probably where he picked this up at. So anyway, let's see if we can breathe new life in this old piece of test equipment. Okay, well first let's go ahead and take the wires off these old batteries. And we'll do them one at a time here. Take the end caps off. They look like they had double-sided tape on the inside holding them on. Let's see what these look like. Yeah, you can see a little bit of corrosion, this white crusty stuff. But they're actually not too bad to be as old. I'm sure these are the original batteries from 1971 or somewhere in that era. So they're not actually that bad. I've seen much worse. What we have to do is we're going to have to reuse these pigtails. Now I'm pretty sure I have replacements. This looks like the same type of connector that we use in radio control models for servo connectors. These are 3-pin connectors. They look identical. So pretty sure I got plenty of new cables if I have to make new ones, but I think we can make do with these. So let's go ahead and see if we can get the wires off. Just need something to stand it up against here. And I'm going to add a little fresh solder to it just to try to loosen it up a little bit. All right, I think it should come out now. Okay. Yep, just fell right out. Okay, that's one of them. All right, just for grins and giggles, let's see if these batteries have any juice in them. Let's see, this is the negative. Doubt very seriously to have anything in them at all. Let's see. Well, 0.834 volts. So that's very little. Surprised as anything. But I'm pretty sure they're no good with the corrosion oozing out of them. All right. Let's go ahead and get the other one. I'll keep the caps separate. I'm assuming the wires look to be about the same length, so it probably doesn't matter which is which. I don't know which is which anyway. I took these batteries out years ago, so I have no idea exactly how they go back on there now. So too late to worry about that now. All right. Let's add a little fresh solder here. And it came off. All right. That one there. And again, let's just see if we got any remnants of any voltage at all. That's weird. It is on voltage, right? Let's see. DC. Okay, now we're getting something. 0.592. Okay, so yeah. Just what I thought. Pretty dead. All right, let's open up one of our new batteries. Like I say, these are all ready to be installed. They put some tape on them here to cover up the leads so they don't short. And it has a nice long solder tab there. And at least they mark the positive end. So let's see if these batteries have any juice. These should, don't know if they'll have a full charge, but they ought to have somewhat of a charge in them. I don't think ni-cads are shipped dry. So let's see what we got here. 5.31, and they're supposed to be 6 volts. So yeah, they're probably like half charged. I think that's the way they usually do it. Whoops. Okay. Now these batteries, the tabs were sticking out. Yeah, there's a little bit of room in those. Let's see. If it's going to fit. It'll be a tight fit because it squeezes on them that heat shrink there. So I did have these labeled top and bottom, didn't I? Well, that's gone out the door now, so I don't know whether to. Well, when I go to place them in the unit, I might have to. Well, actually, it doesn't really matter because these are universal. I just have to figure out which way I need to place them, whether this way, that way, or that way. So yeah, it won't make no difference. Yeah, this one was folded over this way, but the rest of them was sticking out on the edge. This has such a long one and it's down here on the side. I wonder if I should bring them back up to the top like they had them or just leave them on the edge. I could do that, and then I'm going to wrap some caption tape around them. I think I'll do that. Just want something to hold these in place. All right, that's negative. All right, that soldered very nicely to it. I think I got it backwards here. Okay, that's on. Okay. Yeah, that should be good. Now, take some of this tape, which is used for electrical battery insulation, and first I'm going to put a piece on here. Need a pair of scissors out here is what I need, or a sharp razor blade. This razor blade is dull. Yeah, that's dull as I don't know what. Alright, I'm going to go get a pair of scissors. Okay. This should be much better now. Much better. This tape insulates the connection so you don't have to worry about any shorts. It's also high heat. I think that'll withstand, I know it withstands excess of 500 degrees, maybe even hotter. So that's why I use it in wrapping battery terminals in. Okay. Okay, got that end covered. Okay, that one's done. I'll go ahead and do the other one off camera. Then we'll open up the scope and see if I can't figure out the battery placement. And when I do, I'm going to take some more of this tape and just wrap around them to hold them together. So, yeah, and get them lined up, because these little nubs on the plastic, there's a hole in the PC board on the top board and the bottom board where they sandwich in between. So we're going to have to check the fit to make sure they're not too wide, because these didn't have the heat shrink on them. So what we may have to do is, if it's a little bit thick, is peel this old double-sided tape out. I just went ahead and left it in for now, but because we might need a spacer to space it out. So we'll see. All right, let me do the other one and then I'll be back. Okay, well, I got both battery packs wired up. So let's go inside the unit. Let's take the top off here. I'll put that down there out the way. And let me take it off the kickstand. All right, now this top board plugs into a set of plugs on this side, and I've already unplugged those. Here's two of the holes right here where the 4 holes. 2 here and 2 here where the little pegs on the battery sits out. So, and then we got some other plugs that plugs in this side right here. But I'm going to see if I can't, I'm just going to go ahead and put the batteries in and hook it up and see if it works. It may just need batteries. If I can figure out where the batteries plug in, it's been so long. I know they plug on the battery board down there. And you can't plug them in backwards, because these have 2 positive wires and 1 negative wire. The negative wire is in the middle. So the positive wires are on the outer end, so it doesn't matter which way you plug the plug in. So just got to find a plug. Now I did mark it right here, 1 and 2, so battery 1 goes here and battery 2 goes there. But that was battery 1 top, but I don't know if I got the orientation right. I would say that's backwards, because it looks like it's bent down in that position. So with that said, just switch it around. Now these are lined up in the right position because they got little notches here that goes right in between the center cell. So that naturally lines, you know, both of these up so that they should fit in the holes here. And we can just verify, well, yeah, because they're lined up. All right. Now let me see if I can find where they plug in. Okay, yeah, I see it. This one plugs in right here, and that one plugs in right there. So, might need a little help with that. Okay, always helps to have a little something. Now, if we put this down and get it lined up in the holes, it goes right there. And that Don't want to short them because they're open right there, so you can easily short those. Let me clamp it onto wires. Okay, that one's in place. Now, this should be in the right direction because it's pointing down, and that's the top. So, and that's battery number 2. And battery number 2 goes there. So let's see. Yeah, that one is going to be a tight booger to get to. That one is really tight. Okay, since I know the orientation is right, I'm going to put a piece of tape across the center to hold these together, because this one might fall apart on me. Squeeze it as tight as I can. Okay. Now let's see if we can get it in. It's in the holes. Now to get it down in there. Oh boy. That's going to be a good one. Again, I'm going to clamp it on the wires. No, I'm not going to go that way. I can't even hardly see it. It ain't going to fit down in there. All right. I wonder if I can do it this way. Believe I got it. Well, that was a tight fit. But I believe it's in. Okay. Now, let's see if I can get these started. This is a hard little booger to work on. Wait a minute. That's only got 3, and that's got 4 terminals. And this one's got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, well, if I line these up, that has to line up. So let me line these up here. Okay. Wow. That was rough. Okay. That should be it. All right, do we dare turn it on? Here's the on-off power switch. Flip it on, see what happens. Nothing. I don't see nothing. Intensity is all the way up. I don't even hear nothing. Okay. Either the batteries are dead, well, don't have enough power in them. Something is pulling them down. Let's see if we get any movement on the power meter here. All right, let's go ahead and plug it in. Turn it on. Even the power meter is not moving. All right, well, that's a fail. Okay, we're going to have to dig in a little deeper. All right, so I'm going to end this video right here. All right, we put batteries in it. That didn't help us any. So now we're going to have to troubleshoot the power supply. Could have a dead short. One of the tantalum capacitors could be bad. Somebody else had one of these where they had a cold solder joint on the power switch. So that's a possibility. It's a lot of things it could be. So we're just going to have to sit down with it. First check for shorts on the power rails. And yeah, go from there. So there we go. Hope you enjoyed this little video, even though we did nothing but put batteries in and it didn't fix it. So maybe in the next video, part 2, we can fix it. So if you're interested in it, be sure to subscribe to the channel. If you like this kind of content, let me know in the comments. Let me know if you had one of these or used one back in the day. And what do you think of it? Is there a place today, a use for it today? Am I wasting my time? If nothing else, it's a curiosity piece, a conversation piece. And if you're a collector, which I'm not really a collector of antique oscilloscopes, but hey, I have it, so I figured, why not? So, okay, well, this has just been another arcade fix. Have you had your arcade fix today?